Hi everyone, this is going to be a short introduction to Le Chatelier's principle. Le Chatelier's principle states that for a system already at equilibrium, and remember that what we mean by that is that you have reactants and products both present. They're both present and not changing in concentration. Okay, so for a system that's already at equilibrium, if you make a change to that system, you add some more reactants, you change the temperature. If you make a change to that system, it will result in a shift in the reaction towards the products or towards the reactants that partially offsets the change. One of the things that doesn't get stated clearly enough in this is usually the word partially, but it's going to predict how after you add or remove something from the system, is the system going to shift more towards the reactants or more towards the products? So let's look at an example that's used pretty commonly. That's going to be the system 2NO2 gas, which can reach equilibrium with N2O4 gas. So if this is initially at equilibrium, what happens if a additional NO2 gas is added? Well, Le Chatelier's principle states that any changes that are made to the system will result in a shift that partially offsets the change. The change that we've made here is we've added something that is a reactant. So therefore, the reaction is going to shift to the right. The forward reaction is going to speed up. That's going to use up some of that NO2. So it's going to offset the addition of NO2 by using up some of that NO2. So this reaction will shift right. If I can spell, shift right. That means it's going to form more N2O4 as a result of that added NO2. If additional N2O4 gas is added, the opposite will happen because now you've added a product. And so the reaction is going to shift to the left. The reverse reaction is going to speed up. That's what we mean by shift left. The reverse reaction is going to speed up. It's going to go faster in this direction. Okay. And that's going to produce more NO2, which partially offsets the addition of more N2O4. All right. A couple of other things that can happen here in Le Chatelier considerations. This reaction is exothermic. You're forming additional bonds, not breaking any. So it's exothermic. We tend to think, therefore, of heat as a product because remember, exothermic means you're producing heat, you're warming the surroundings, so heat's coming out of the reaction. So we actually write it just for this one time, as though it's a product. So this helps us think about what happens if you raise the temperature. If you raise the temperature, it's like you've added more heat. The reaction is going to shift left to use up that heat. That's going to produce more NO2 gas. Right? Slightly weirder thing that happens, let's say you increase the volume. Right? The way the reaction offsets that increase in volume is it occupies that volume. Okay? It's going to take up that volume. It's going to occupy that greater volume by shifting to the left. Why? Because on the right-hand side, you only have one N2O4 particle, whereas on the reactant side, you have two NO2 particles. Remember from first semester, this is Avogadro's hypothesis. The pressure is proportional to the number of particles. It doesn't have anything to do with how big those particles are or what those particles are. The more gas particles you have, the higher the volume or the pressure. So here, it's when you raise the volume on something by giving it more volume to take up, it's going to occupy that volume by shifting, in this case, left to occupy more volume that's going to produce more NO2 gas. All right. You should work the first exercise in the course packet and then check your answers for that one with the second video in this set on Le Chatelier's principle. We're also going to do a lab and some demos on it. All right. Thank you.